Good afternoon, everyone. I hope that everybody's doing great today. Today we're looking at lesson 30.11, which deals with what are called logarithms. And logarithms are an entirely new concept to you. You haven't seen a hint of any of this kind of math up until this point. So it's going to be really, really new for you. This lesson can be found on page 9 of your current lesson handout. Now, if we had more time, and we don't, I could go into more detail about where logarithms come from, but I'm cutting to the chase here and giving you, I guess, what I think is the basic facts of logarithms that you need to know. And that's that a logarithm is a rearrangement of an exponential equation. I'll get to what that is in a second in the second line, but if I told you that a was equal to 3c, and I said to you, rearrange that for c, I don't think too many people would blink an eye here. You would think about it for a minute and say, oh, c is equal to a divided by 3. I have to do the opposite of multiplying by 3, and the opposite of multiplying is dividing. If I told you that a was equal to c plus 8, and I said to you, what is c? You would say, well, c is equal to a minus 8. And in fact, these expressions are the same expressions. They're just disguised differently. They're rearranged differently. Now imagine that you are in, I don't know, maybe grade 4, and your teacher all of a sudden says a equals c squared. And she asks you, what would c be equal to? Well, this concept of undoing multiplication by dividing, you would know at that level. And this concept of undoing addition by subtracting, you would know. But the concept of undoing a squaring is something that would be foreign to you. So your teacher would have introduced to you, and I don't know the exact grade, but she would have introduced to you somewhere along the way that you have this new symbol, and it looks like that, and basically it's the opposite of squaring. You, of course, don't learn about the plus or minus until you get to grade 11, but that's okay. It's the same thing that's going on here. When I ask you to rearrange a equals b to the c for c, we have to introduce a new way of writing things, and we write what is on the right-hand side of this screen. The item on the left is pronounced a is equal to b raised to the c. The item on the right is pronounced c equals log base b of a. And the thing I want you to notice is that c is the exponent. When you take a look at the left-hand equation, c is the exponent that you raise b to get a. And you need to be proficient at converting these back and forth. So much so that if you were a bilingual person, you can compare this to these two words, oui and yes. If you are truly bilingual and you are thinking in French at an instant in time and I say yes, you understand what it means. If you are thinking in English and I say oui, you understand what it means. You're able to convert those back and forth. So we have to start with being able to convert this expression, which is an exponential expression, to this expression, which is a logarithmic expression. They mean the exact same thing. So convert each of the following from exponential form to logarithmic form. What I would like to impress on you is that a logarithm is an exponent. And there are going to be a couple of advantages to thinking that way. The first one is to remember that we have to write this as a logarithm. Well, the logarithm is the exponent, which means it's going to be equal to p. We have n equals 4 to the p, so p is the exponent. It's the logarithm. It's a base 4 logarithm of n. P is the exponent to which you raise this base to get this thing. When you convert from one to the other, I'm going to go back and look at this again. It's important for you to remember that the base is the same in each. So you have two other pieces to either of these expressions. What you're looking at on the board, those pieces are A and C. In the exponential, one of them is by itself, and in the logarithmic, the other is by itself. That's a way that you can remember this. If we have 2 raised to the negative 5 is equal to 1 over 32, how do we write this as a logarithm? Well, it's going to be a log base 2 of 1/32 equals negative 5. So the base is 2 in both cases. The 1 over 32 is by itself in the exponential form. The negative 5 is by itself in the logarithmic form. Another way you can look at it, and this is really going to be useful in a few minutes, is that this statement here, and I want to write it down, is saying negative 5 is the exponent to which you raise to get 1 over 32. It's very, very useful when you see a logarithmic expression to read it that way. Incredibly useful. Convert each of the following from logarithmic form to exponential form. Well, I want to actually write out what this means. 2 is the exponent to which you raise to get 100. If you can look at a logarithmic expression and read it that way, then you are converting it to exponential form. You raise 10 to the 2 to get 100. What is m equals log base x of k saying? It's saying that m is the exponent to which you raise x to get k. In a logarithmic expression, the item that's by itself is the exponent, because the item that's by itself is the logarithm. It's equal to the logarithm. Determine the value of each of the following. I'm going to introduce an x here. X is the exponent to which b is raised to get 1. In other words, if I rewrite this log base b of 1 equals x in exponential form, I get this. And now we have to go back to a grade 10 idea and say, well, what exponent do I raise a base to get 1? 0. So this expression is equal to 0. What this is saying is, and I'm not going to write it down this time, I'm going to try to work away from having to write this every time. Log base b of b is saying, to what do I raise b to get b? Well, you raise b to the 1. To get b, which means that log base b of b is 1. We write this out, log base b of b to the n. This is saying, to what do I raise b to get b raised to the n? Well, you raise b to the n to get b to the n, which means that log base b of b to the n is n. This is going to require a lot of patience and thought on your part. It's new to you. What is log base 2 of 64? Let's call this x. This is saying, what do I raise 2 to get 64? The second one is saying, to what do I raise 6 to get 216? The third one is saying, to what do I raise 3 to get 81? And we've already learned how to solve these. You want to find a common base. With a little bit of help on your calculator, you will discover that you can write 64 as 2 raised to the 6. With a little bit of help on your calculator, you will discover that 6 cubed is equivalent to 216. And with a little bit of help on your calculator, and probably, I hope, a little bit of thought on your part, you will discover that 81 is 3 to the 4. So since the bases are the same, the exponents are the same. Which means log base 2 of 64 is equal to 6. And I would probably say to you that many people would be capable of going from here to here, because you're just going to look at what I've circled and say, to what do I raise 2 to get 64? And you'll figure out what number you raise 2 to get 64. Similarly, if I say to you, what is log base 6 of 216? If you know that that's the exponent to which you raise 6 to get 216, then you figure out that 6 cubed gives you 216, which means the logarithm is equal to the exponent of 3. If I said to you, what is log base 3 of 81? Well, you're saying, to what do I raise 3 to get 81? The exponent is equal to 4. When the base of a logarithm is not written, for example, log 8, it's understood that it's base 10. So what is log of 10,000? That is log base 10 of 10,000. By the way, I haven't pointed it out to you, but the word log, and the number that you are logging, if that is a verb, are on the same line. The base is really written down below. So log of 10,000 means log base 10 of 10,000. Log of 0.001 is log base 10 of 0.001. And what this is saying is, to what do I raise 10 to get 10,000? And what the other one is saying is, to what do I raise 10 to get 1 over 1,000? 0.001 is 1 over 1,000. Well, 10 raised to the 4 would give you 10,000. 10 raised to the 4 is 10 times 10 times 10 times 10, which means that the exponent is 4, so the logarithm is 4. 1 over 1,000, which is 0.001, is the same as 10 to the negative 3. 10 to the 3 is 1,000. 10 to the negative 3 is 1 over 1,000. That means the exponent to which you raise 10 to get 0.001 is negative 3. Determine the value of x in each of the following. So we have 3 raised to the x equals 27, and we have to solve that. With a little bit of thought, you will understand that 27 is 3 cubed, so x is equal to 3. Log base 27 of 3 equals x. That means 27 raised to the x this time is 3. We're going to solve this by finding a common base. 27 is 3 cubed. When you have a power of a power, we're going to multiply the exponents, which will give us 3 to the 3x equals 3. And 3 is 3 to the 1. Since the bases are the same, the exponents must be the same. So when I divide both sides by 3, I get a third. When we write this in exponential form, we get x to the 4 equals 81. There are two ways that you can go about solving this. You could say that to get x by itself, I need to take the fourth root of both sides. So you'll get x equals the fourth root of 81, and you can figure that out to be 3. The other thing you could do is just say, well, I know that 3 raised to the 4 is 81. There's actually another thing that you could do, and it's, now that I think about it, probably what I would recommend. If you have x to the 4 equals 81, what you can do to get x by itself is raise both sides to the quarter. Because on the left we have a power of a power, which means you're going to multiply those exponents, and you will get x raised to the 4 times 1 over 4 equals 81 to the quarter. 4 times 1 over 4 is 1, so you get x equals 81 to the quarter, which of course is the fourth root of 81, but you don't have to go hunting for a root function on your calculator. You can just enter 81 raised to the 0.25. Anyway, you get 3. Log base 5 of x equals 3. In case it hasn't dawned on you, and that's my fault, I probably should have mentioned this a lot earlier. When you're trying to make sense of a logarithmic expression, rewrite it in exponential form. So anytime you have a logarithmic expression, if you don't understand what it means, write it in exponential form and the meaning will become clear, hopefully. Well, x is 5 to the 3. All we have to do is take our calculator and go 5 raised to the 3, which is 5 times 5 times 5, and we get 125. E, log base 1/2 of 32 equals x, so we're going to write this in exponential form. We're going to go back to the previous lesson where we write things as a common base. The common base is 2. 32 is 2 to the 5. 1/2 is 2 to the negative 1. Now that we have a common base, let's pack these exponents together. Negative 1 times x is negative 1x. When you have a power of a power, you multiply the exponents. Now that I have the same base on each side, I can say that the exponents must be equal. When I divide both sides by negative 1, I get x equals negative 5. There are a lot of examples there. There are a lot of things you need to study here. Because logarithms are new to you, not even just a little new, totally new to you. You have never heard of them prior to today. You're going to have to, as my dad would say, buckle down here and really, really study the examples we did. Take a look in your textbook for extra help and figure these out. On page 380, questions number 2, 3, 12, and 14. Tomorrow is a Google Meet day, so if you have any questions at all from the last week's lessons or so, please show up so that you can get them answered by me. Your next assignment will be available to you tomorrow as well, so you're going to have something else that you can work on tomorrow if you're not having any difficulties with logarithms. And then Friday we're going to move on and look at the laws of logarithms. So good luck with your homework, and I hope you have a wonderful day, and I will talk with you soon.